let's talk about how to find the area of circles. And today there's going to be a few words to note. Okay, I'm just going to write these out first. We have diameter, we have pi, we have radius, and we have semicircle. And we've seen these words before, so these are not new, okay? But just to recap, the diameter is a line that goes across the circle. The distance across a circle through the center. So it could go in any direction like that, okay? Through the center. Radius is going to be half of the diameter. So from the center to any point on the circle. That's the radius. Okay, so radius is half of diameter. Pi is approximately 3.14, or in fraction form it is 22/7, and then pi is represented in math. Pi is this Greek letter, looks like this, and then semicircle just means half of a circle. Okay, half of a circle. So the formula for the area of circles is pi times radius squared. Pi r squared. So let's try some sample problems involving circles, and let's find their areas. Okay, so let's look at a couple of circles and figure out what their areas would be. So say this one here, the diameter is 4 inches. And then this one here, radius is 5 yards. And then let's have one semicircle with a radius here of 20 millimeters. Okay, let's figure out their areas. So remember, area for a circle is pi r squared. Okay, so this first circle, if it's 4 inches across, so the diameter is 4 inches, what would the radius be? Because we need radius, not diameter. Well, the radius would be half, right? If this is the diameter, the radius is just half of it. So radius is 2 for this first sample, okay? So the area of this circle would be pi times 2 squared, pi r squared, r is 2, which is going to be 4 pi. And again, you could keep going from this, like 4 times 3.14, or 4 times 22/7 if you wanted to, okay? But 4 pi. What about this one here? Well, this one, the radius is 5 yards. Okay, so for this one, the area would be pi times 5. 5 is r, 5 squared, or 25 pi yards squared. 25 pi yards squared. Okay, this would be the area. Oh yeah, and this one I guess we could, or we should label it 4 pi inches squared, because it's inches. Okay, and then this semicircle right here. So semicircle is half of a circle, and the radius is 20. So if we plug in to the formula, this area would be pi times 20 squared. But since this is a semicircle, half of a circle, remember to divide it in 2. Okay, so half of a circle. Semicircle, so we need to divide by 2. So this one, 20 squared would be 400. Right, 400 pi over 2. And then 400 divided by 2 would be 200 pi millimeters squared. Okay, this would be the area of this semicircle right here. All right, let's look at another sample now. So, how about this one? Example 1. Say we have a sprinkler, okay, so like a lawn's sprinkler to water the grass. And the sprinkler, you've seen these sprinklers typically rotate, right? They can spin around like that, right? So if we have a sprinkler and the sprinkler can spray water to a radius of 7 feet. What area of a lawn can it water? Okay, so if we have a sprinkler and it can spray water in 7 feet and rotate, what area of a lawn can it water? Okay, well, the area of a circle is pi r squared. So we just need to find the area. Let's just plug in 7 feet for our radius. So for this circle, representing the area that the sprinkler can water, our radius is 7. So let's plug that in here. Okay, so area is going to equal pi times 7 squared. 7 squared is 49, so our area is 49 pi. Okay, now at this point, if you wanted to get more specific, you could either plug in 49 times 3.14 and just multiply that out, or you could do 49 times 22 over 7. So it kind of depends. Maybe the math problem will ask you to do it in decimal form, maybe in fraction form. If you wanted to get more specific than 49 pi, you could do one of these two ways here. Okay? All right, let's try another problem. So this time we have a doorway. That is not a straight door. Okay, we have a doorway, and at the top we have a dome as its decoration. And let's say this doorway right here, I'm just going to add a little knob. Okay, this doorway right here. This doorway is 3 meters wide. So it's actually a giant doorway. 3 meters would be a very wide doorway. Okay, but just for our sake, 3 meters. And say we wanted to know the area of this dome. What is the area of the dome? Well, let's start with our formula. Area of a circle would be pi r squared. Now, this dome, how does it relate to a circle? So a circle obviously would look something like this, right? And this dome, well, it's actually half of a circle. Right, so this dome is a semicircle. It's one of the vocab for today, semicircle. It's half of a circle. So if this is the formula for a circle, the formula for a dome, a semicircle, would simply be pi r squared divided by 2. Because a semicircle is half of a circle. So we are going to take the circle's area and divide it by 2. Okay, so half of the circle's area. Now it's going to be pretty easy. Let's just plug in 3 in the appropriate place. Okay, so one more step. If 3 meters is the width of the door, that means 3 meters would be the diameter, right? Diameter. So if the diameter is 3 meters, what would the radius be? Because we need the radius, r. Remember that radius is half of the diameter, right? Radius would go from the center of the circle out. So if the diameter is 3, the radius would be half of that, which is 1.5. So let's plug in. We have our area is going to be pi times 1.5, that's our radius, squared, over 2. Okay, and at this point, I guess you could use a calculator to figure it out. Pi times 1.5 squared divided by 2, and then you would get that the answer, the area for the semicircle, is approximately 3.5 meters squared. Okay, that would be the area right here.